Hello students, welcome to BTech first year physics course. In the last lecture, we have discussed some preliminary concepts on scalars and vectors. We have seen different types of vectors, then the concept of scalar field and vector fields. Now today, I shall discuss the dot product, cross product and triple product of vectors, because these prerequisites are very much essential to understand the vector calculus, which we are going to discuss from the next class. Okay, so let's start with the dot product. So when we are doing the dot product, we require two vectors. So here A and B vectors. So if we perform the dot product, the magnitude will be the magnitude of A vector multiplied by magnitude of B vector, then cos theta. So here theta is the angle between these two vectors. Now if we think the vector form of A vector and B vector are like this, then if we perform the dot product between them, then we get this value. That means if we perform the dot product, it will give us scalar quantity, right? Now what is the physical significance or physical explanation of dot product? So basically, if we perform the dot product, that means we are taking projection of B vector on A vector or projection of A vector on B vector. Okay. So in both the cases, the value will be same. Now the example is work done, that is applied force dot displacement. Means the dot product of applied force and displacement will give us the work done. So work done is scalar quantity, right? Now let's understand the cross product. So here A and B are these two vectors and the angle between them is theta. So if we perform the cross product, then this will be the form. So magnitude of A multiplied by magnitude of B vector, then sin theta and n cap. Now what is this n cap? N cap is the perpendicular on this area. So this is normal on this area, unit normal. Okay. So this will give us the direction of this cross product. So n cap is the unit normal along the direction of A cross B. Now how can you find out the n cap? You can find out by right hand screw rule. So A cross B means we have to rotate the screw from A to B. Now if we do B cross A, that means we have to rotate the screw from B to A. So in that case, the movement of the screw will be along the negative n cap direction. That means in downward direction, right? So that means A cross B is actually minus B cross A. Now, if the vector forms of A and B are like this, then if we do the A cross B, then we can get this form. And you can see this is another vector. Okay. Now, let's understand the triple product of vectors. So, to start with, we will consider first the scalar triple product. And here we require three vectors, right? So A cross B will give us the direction and the magnitude along this direction. Now if we do the dot product with C, that means we are taking projection of C along A cross B. And it is actually give us the volume of this parallelepiped. So scalar triple product will give the volume of the parallelepiped. Okay. Now another is vector triple product. So that is like this, and if we do the calculation, we can get this form. Now the triple product involving del operator. So here this is called the del operator, and the form of the del operator is like this. So these are the partial derivative with respect to the x, y and z. So this is basically differential operator. Now del cross A, this form will be similar to this. Okay. Now this has tremendous significance in electromagnetic theory. Now instead of A, if we consider electric field and magnetic field, and if we calculate and if we use the Maxwell's equation, we can reach to the electromagnetic wave theory. Okay, so this is the significance of this triple product involving del operator. So today I am stopping here. In the next class, we will start the vector calculus. Okay, thank you.